So now that you've learned about the types of forces and how to draw force diagrams, now I'm going to show you how to write net force equations. Now in math class, up has always been positive, down has been negative, to the right has been positive, and to the left is negative. So we are going to keep those same things, and now we're going to write an equation to solve the problem. So when we are doing net force equations, the first thing to know is that we are going to use this little sigma, is what it's called. It is a Greek letter, and it means the sum. So we are going to add up everything when we see sigma. And so specifically, we are going to add up the forces in the x direction. So Fx means the forces in the x direction. And then up here, we said to the right is positive. So anytime we see a force going to the right, we are going to add it. And anytime we see a force to the left, we are going to subtract it. So it'll be a minus whatever forces are to the left. So let's go ahead and take a look at some examples. We're going to take a look at a bird sitting on a stump. So we already said that there's a normal force acting up on my bird. And then we also have gravitational force on the bird by Earth. And so in the x direction, I'm going to add up the forces in the x direction. There's nothing in the x direction. So now we need to go back and all right, so that's really easy. There's no forces in the x direction. So we're just going to say we add up all the forces in the x direction and there's nothing. All right, so then we do the sum of the forces in the y direction. And we're going to do it the same way as the x direction, but now we have what goes up is plus and then minus what goes down. And in this case, we have normal force going up, so plus my normal force. And I don't need to write the on the bird by the stump. I'm just going to write Fn. Minus gravitational force, because that's what's going down. And then it's always equal to ma. Now, let's just say for a moment that I wanted to solve for the normal force of the bird. So what is the normal force? And we're just going to say that the bird has a mass of 5 kilograms. It wasn't originally given, but it would normally be given if I was going to have you solve for this. All right, so first of all, I need to figure out what I'm trying to solve for. I'm trying to solve for normal force. So I'm not going to know what this is, so I'm just going to leave it Fn. And that is one variable. Minus my gravitational force. Well, one thing to remember about gravitational force is that gravitational force is equal to your mass times the gravitational field strength. And on Earth, our gravitational field strength is 9.8. And this bird lives on Earth. So that means that my gravitational force then is going to be equal to the mass of the bird, which is 5 kilograms, times 9.8, because that's G. The units are newtons per kilogram. So my gravitational force of this bird then is 49 newtons. All right, so I'm going to plug that in down here, 49 newtons for gravitational force. And then I know the mass of my bird is still 5, so that equals 5 times, and my acceleration is 0 because it is not speeding up and it is not slowing down. So 5 times 0, that means 5 times 0, well, oops, that's just going to be 0. So now I'm going to rewrite this. I have normal force minus 49 is equal to 0. So I add 49 to both sides, and I get a normal force of 49 newtons. All the forces you put in these net force equations should be positive numbers. You are accounting for if it's going up or going down because you are using these pluses and minuses. So all the numbers you put in for a force and all the numbers you should solve for when you get a force should be positive. All right, so that's the bird. For my ice skater that's moving with constant velocity on frictionless ice, again, the sum of my forces in the x direction is 0 because there's nothing going to the right or to the left. And I'm going to just work on writing my net force equation here. So the sum of my forces in the y direction, I have plus what goes up, and normal force is what goes up, so that's plus Fn, minus what goes down, which is my gravitational force, so minus Fg, equals mass times acceleration. And then I'm going to just rewrite this. And because she's moving with a constant velocity in the x direction, the acceleration in the x direction is 0. Because she's not moving up or down, she's not accelerating up or down, she's not jumping, she's not falling. That means my acceleration for the y direction is also 0. So mass, again, times 0 is going to be 0. So this is my net force equation. This one gets a little bit more complicated because now we have x and y directions. So when we do the sum of my forces in the x direction here, I am going to have a push force going to the right. So that's a plus Fp. And I'm going to have minus frictional force because frictional force is going to the left. So minus frictional force. And again, there's constant velocity. Constant velocity means that my acceleration is 0. So I'm going to write equals ma. And then I'm going to say, acceleration is 0. So I get my push minus my frictional force is equal to 0. Now, as you're doing this, when I ask you to write a net force equation, I want it to not have any numbers in it. I want all letters. So it should be looking just like this. Even if you have all the numbers that go into that equation, I want to make sure that you guys are only giving me the letters for your net force equation. Once you've written that, then you can go ahead and substitute back in and give me actual other things with numbers. So now I'm going to do the sum of my forces in the y direction. Up is positive, so plus Fn, minus gravitational force, because that goes down, so minus Fg, equals ma. Again, not accelerating up or down. She's not speeding up or slowing down, jumping, or anything like that. So my acceleration again is 0. So I have normal minus my gravitational force equals 0. Now, in this one, she is speeding up and there is friction. And so we need to actually have an acceleration in this one. So let's do the y direction first. So the sum of the forces in the y direction. And I'm going to have normal force go up because that's positive. And minus what goes down, which is gravitational force. And that's going to be equal to mass times acceleration. And I want to be clear because this is the y direction that I'm doing this for. I need this to be the acceleration in the y direction. Now, she is accelerating, but she's not accelerating up and down. She's only accelerating to the right. So this acceleration is still going to be 0 because she's not accelerating up and down, and this is the y direction. So we have normal force minus gravitational force is equal to mass times 0 is 0. And there we go with the y direction. All right, so my question here is, what is the acceleration? I've given you a push force of 20 newtons, frictional force of 5 newtons. Her mass is going to be 75 kilograms. And I want to solve for the acceleration. So we're going to do the sum of the forces in the x direction. So first, we're going to start with what goes to the right. So it's a plus my force push because it goes to the right, minus my forces that go to left, which is frictional force. And that's going to be equal to my mass times acceleration. In this case, my force push is 20. My frictional force is 5, so I have minus 5. And that'll be equal to my mass, which is 75, times my acceleration. So then all I need to do is 20 minus 5, which is 15. And that's going to be equal to 75 times A. To get rid of the 75, I divide by 75 because it's multiplied. The opposite of multiplication is division. And I get 15 divided by 75. And so that means that my acceleration is 0.2 meters per second squared. And that's her acceleration. All right, we're going to skip a few here because I want to go and focus on this one right here where we have a basketball that is in free fall. So the sum of my forces in the x direction, again, are just 0. There's nothing going on there. The sum of my forces in the y direction is just gravitational force. There's nothing going up, so there's plus nothing, and then minus Fg, and that's going to be equal to ma. Now, I'm not given the mass of the thing, but we're just going to leave it like that. We're going to plug in again that gravitational force is equal to mass times g. So I'm going to keep that negative or that minus sign because that gravitational force was going down. So minus mg, and that's going to be equal to mass times acceleration. Divide both sides by m. Those m's are going to cancel out, and you get negative g is equal to your acceleration. And because we're on Earth, we're going to put in 9.8, so we have negative 9.8 meters per second squared is equal to your acceleration. And what's interesting about this is mass does not matter because it will cancel out. And that's why when you have an object in free fall, throwing a keys out the window, throwing a ball in the air, everything's going to accelerate downwards with negative 9.8 meters per second squared acceleration. If you've got questions, let me know.